We have some questions that were submitted in this form, and I will just start reading some of them. And if anyone has a question that arises from the questions that we are discussing, you can anytime interrupt and ask your own questions. Okay, so the first one, and I think it would also be a good idea to get for us to get to know you a little bit better. Could you go quickly through your career path and how this led you to writing this book? How did you get the inspiration for that, and also the knowledge for writing this book?
Okay, well, so once again, thanks for the opportunity you just gave me to answer some questions and to talk about reproducibility. It's always a pleasure to talk about it. So I'm quite happy to be here today. So regarding the questions, so there are several things. First of all, I would say that I was always interested into questions of reproducibility. As Julia mentioned at the beginning, I hold a PhD in economics, and so I had a short, but still had a short career in research. And so for me, it was always kind of obvious that you had to make sure to some extent that your research is reproducible. Now, of course, I also went through it, and I see that in practice it's not always easy. Even though everyone agrees in principle that science should be reproducible, it's not always in practice possible or easy, or maybe you don't have the support in your institution and so on to actually do it. But lucky enough, I had a project, and I think it really started there. I had a project together with some researchers from the University of Mannheim. And basically, they were quite advanced, or that team at least were quite advanced in terms of reproducibility, and more generally speaking, in terms of software carpentry. That was kind of the term they were using. So you have software engineering, which is hardcore programming and so on to build business software, let's say. And then you have a more, I wouldn't say lightweight, but maybe focused version, and focused on certain best practices and on reproducibility, that is called software carpentry. And there's actually, I think, even a foundation that builds courses and so on and so forth. And at the time, the PI, I think he took those courses, or he was involved with them in some capacity. I don't remember exactly, but essentially he forced us to work according to these principles. So we used Git, we wrote unit tests. Actually, we had before we committed our code to Git, we had to run the tests and make sure that everything was still okay, and then only we could commit and so on. So that was my first exposure to this kind of topics and ideas in very practical terms for a research project. And I thought it was really interesting because not only it made sure that our code was and our research was of higher quality, and it also made collaborating much easier, because you were always kind of certain that in the mornings when you were starting from a sane base, because everyone had to make sure that whatever they didn't break anything, because you had to run the tests before pushing. So this was really important. Then when I went into, so actually before going to PwC, I also worked as a research assistant here in a small lab in Luxembourg. I say small because it's a lab that is attached to the National Statistical Office. So it's not. So we have in Luxembourg, we're a small country, so we don't have that many research institutions, and that one is or that team is not part of one of the big research institutions, but really part of the National Statistical Institute. And there, because we were in the same building, right, in the same premises, I was in contact with a lot of the statisticians. And even though they weren't using, not all of them were, and most of them weren't using Git or using tests, they were still very paying a lot of attention on making sure that there was a certain procedure to go from the raw data to their statistics, and that they were following it precisely. And Eurostat is also quite keen on making these things work smoothly. So there are a set of guidelines, there are a set of best practices that get published, but not necessarily in terms of software carpentry, but more in terms of like quality assurance and making sure that you have a process that is clearly documented and that you follow. And I thought that that was quite interesting as well, because it ensures as well the quality of of the statistics. And then when I went to the private sector, I realized that they basically do the same thing, but they do it in a way that is more, software engineering oriented. So they use Git internally. We used Git. We used, all kinds of tools, unit tests, and so on and so forth, to ensure that everything that we were making and building and also selling, was actually of quality, because we didn't want, something to just explode in our hands in front of a client or something. And there it was also quite important to ensure that everything you did, you could redo, because I was always getting asked again and again for small variations. Could you do this now? Could you add this? Could you repeat the exercise, but with this new data? Could you, and so on and so on and so forth. And I quickly realized I had to make sure that I had to deal with everything that made it possible to have my results reproducible, because if not, I would end up in a situation where I would say something and then I would get asked again 6 months later, or even 6 weeks later, or 6 hours later, and all of a sudden the code produces something else for some reason, and that would be quite a problem. And that actually happened to me during COVID, because when COVID happened, I was already working for the public sector at that time, and I was helping out so we had, like in every country, I guess, like a task force dealing with data and so on and so forth. And I was helping one team with just getting some statistics, aggregate statistics on infections and things like that. So very basic stuff actually, and I was helping them. And there was an issue that the platforms that we were using were platforms where you had maximum security. So basically you couldn't leak any data or anything like that. But this also meant that you couldn't install anything on them, right? And because reproducibility was not really a major concern usually, we had nothing to ensure that our code was reproducible. And there were several situations, several cases where we produced a result, and some weeks later we were asked, hey, that was someone would tell us, hey, that's a weird result, or could you look into that again, and so on. And we went back and the result now was different, and we didn't really know how, but probably changes in the data, because the software stack was stable, that didn't change. So probably changes in the data, or maybe mistakes that we did and then we corrected, and we don't even remember that we corrected, because we don't have any, we couldn't version our code. And we were working like, we were working at that time like 12, 14, 16 hours a day. So we wrote so much stuff, we don't even remember when we corrected something. So then we would ship code that was actually based on mistakes, and in the meantime we had corrected that. So when we go back, actually the result was different. It was correct but different, and we weren't able to explain. And so this was really an experience where I thought, okay, we need to make sure that everything we do is reproducible. In those platforms that wasn't possible, but after COVID and now with my main job, now I make sure that everything I do, I always control exactly which data set, which software stack, and so on and so forth. And so basically this whole, I was lucky because I was exposed to that through my PhD. And then I was also curious, I took the time to learn these tools and so on, and also through my jobs. But I guess, yeah, it was really a mixture of being exposed to the right people, this PI in Germany that made me learn about software carpentry, and then at PwC, where we needed to be, everything needed to be absolutely of high quality, because we were selling stuff. And then during COVID, where I realized, okay, if I don't have the possibility to do that, problems emerge, things happen. So I really need to make sure that everything is correct. And now essentially the main motivator is that I work for the public sector. So we're not selling anything, but we do have, and we do want people to trust us, right? We do want to keep the trust of the people, right, of the citizens. And so we really want to make sure that if we publish a statistic or some data set, whatever, we really want to make sure that if we need to revise it because we realize there is some mistake, that we can explain why, what happened. So this is something that we always try to do. So for now, thankfully, nothing major happened, but this is really important to us because it's more now, yeah, a question of trust, I guess.
Yes, thank you. It's interesting for me to hear your experience with the public sector and in the industry. And it's at the same time a bit funny and a bit scary how behind we are in academia in writing this reproducible code and analysis. Okay, we could go to the second question. That is, what do you think that are some common challenges that people face when trying to make their projects reproducible?
Well, I thought a bit about this question, and I mean, of course, there are the more technical aspects, right? I mean, that's obvious. I mean, you have to learn these tools. These are not things that you would learn like as part of a course usually, especially if you're not studying software engineering. Like if you're if you're studying psychology or economics or things like that, well, you study economics or you study psychology, you study biology. You don't study these things. So that's, of course, that's one first challenge is this cost of entry is quite high. And then I think another challenge is maybe more psychological, and it depends, I guess, on people. But because the cost of entry is so high, you could get discouraged quite quickly, I would say. And you could say, well, I'll just pay attention. I'll just do something else, but I won't, I won't learn about Docker. I won't do that because it's just too much, right? And the book is my attempt at making it more accessible. So trying to write something that hopefully someone that is not too experienced can can use, but it is a difficult topic, right? It is not it is not easy, and so you could get discouraged. And I think that is the biggest challenge: is you have to grind your teeth and you have to keep at it for some time, and then you get used to it, and then it's second nature. But yeah, the entry cost is really high.
This connects to the other question that is saying, do you have any suggestions for encouraging the practice of reproducibility in research groups who are slow to incorporate the mindset and practice? Is there a step that would be the easiest hurdle to overcome? Time constraints to learn new methods is usually an issue, as you said.
Yeah. Well, it really depends. It really depends on your team, and it depends also, as I would say, on the position you have on that team. Right? It's very difficult for a very junior member to come with this kind of ideas because, well, they're full of energy. They're young, and but yeah, that's not really research. Research is this other stuff that the seniors do. So it can be very difficult. If you don't are yourself already in a position where you can say, well, we're going to do it this way because this is actually how we should do it. It can be very difficult. One thing you could try is try to make it, if you can, and again, it depends a bit on your team, on your institution, but if you can, make the transition as smooth as possible for everyone else. So for example, you could say, well, here is, and to go back a bit to the book, here's an RN-vlog file, okay? And you are going to all use this RN-vlog file, and I can, do it for you on your computer. I go physically to you, and I, start and configure RN so that you can use it. And then everyone has the same packages already. That's already not too bad, right? So this is something that you could try to do, or if you have the luck that you have some Git versioning control platform in your institution, like GitLab, or if you do have GitHub, if you have GitHub Enterprise, for example, if you're lucky, you could say, well, I'm going to set up the repository, and I am going to write all the tests that should run each time you push, right? And so we know, so you don't have to do anything, you just work as usual, and you push, and then I get the tests. And then, of course, if people don't know how to use Git, and if they don't want to use Git, then it's really difficult. Then it's really difficult, because these habits, to change these habits, it's extremely complicated. So there may be an alternative would be to say, well, we can use, for example, the Git client that is included in our studio. So it's graphical, you can click, and it's easier to use than maybe, using the terminal, things like that. But it's extremely difficult, and usually, at least in my experience, it's either people are already kind of convinced that this is the way to go, and so they use it, or you can maybe have a project with like-minded individuals, and you use these techniques with like-minded individuals, and then in a seminar or whatever, you come and you show, hey, this is how we worked. This was great. We were able to do so many things. We have full transparency because we have the whole Git log. We can rerun the code like this. And then maybe you can convince some people because, improved productivity, etc., etc., etc. But it's extremely difficult. It's extremely difficult. If people are not already in the mindset that this is the way to go, then yeah. And if you are in an institution where you don't have any Git, you don't have any platforms where you can use these things, it can be really, really difficult. One suggestion would be really to go to people one by one, make their lives easier by, for example, just using RN to at least have the same packages. Maybe do a little, tutorial presentation seminar on Git, and like some slides where you show, hey, you can do that with Git. It's not that hard, and it saves a lot of headaches in the long run. But yeah, I unfortunately don't have a magic recipe for that one. I wish I had, but.
You would say then that GitHub is like the minimum requirement?
Well, I don't remember who said that, but some developer or software engineer said that code that is not versioned using GitHub or whatever, GitLab, but code that is not versioned does not exist. And it's true, because if you don't have any way of synchronizing, at least just synchronizing and collaborating, it's extremely difficult. And there are some alternatives that you could use, like Dropbox or things like that. But the problem with Dropbox is that it doesn't handle conflicts. So if you both change the file, then you have to merge by hand. So you end up wasting a lot of time doing the merges by hand and so on. So I would say, yeah, Git is really the minimum, and something like RN to at least have the same packages. I would say both things are really, really the absolute minimum. Yeah.
And I was thinking also, so when you have a bit more seniors, so in academia, I cannot say for other areas, but when you have like a professor that is in a really long time in academia and they have a really long career, I feel that there is some resistance in, for example, sharing the code. So people are kind of being forced to share data now by journals. But still, there is a lot of resistance to share the code, because I think maybe they think this could affect their reputation or something like this if someone will find a mistake. How do you think we could deal with that? Because I understand their side, but at the same time, isn't it good if people find the mistakes and we try to correct them instead of we are just believing in some results that are not actually true?
Yeah, so my position is very radical here. So for me, if I read a paper and there is no code and no data, I just don't believe the results. Unless the data cannot be shared because it's very sensitive personal data, then okay, fair enough. And unless the results have been replicated several times by other teams, by other researchers, then I'm starting to believe it. If I were still a researcher, my position would be to put at least the code out. And why? Because then I could say, hey, I have nothing to hide. Here's the code to my paper. Any mistakes that you may find, and you will, but any mistakes are not done on purpose. Now, I think it's much more suspicious, right, if you hide your code and if people end up finding something. And then, what is your defense? So what I could argue with colleagues like that would be to say, actually, putting out your code is actually the best defense, because just put it out. I mean, unless there is really something that is, I don't know, completely sensitive, but usually with the code, there's not many issues. Just put it out. It's the best defense. And that's it. Same if you develop like a novel algorithm. I knew cases like that in economics where people would develop these cool new algorithms, but before publishing the algorithm, they wanted to write like 3 or 4 papers, and then they could publish the algorithm. But for me, this is even more dangerous, because you publish your first paper where you describe the algorithm, someone else can re-implement it. Once it's on paper, it's over basically. But if you publish your code with it, then you are the author, right? You are the author. And people cannot deny that anymore. So it's a very weird, in my opinion, very backwards way of looking at it. My argument, and people, they have their habits, very difficult to change. But my argument would be to say, actually, to protect yourself, the best way is to share your code, actually, because then people, if they notice something, first of all, as you mentioned, you can improve actually the code and the results. That's one thing. And you don't have to go through maybe an embarrassing process of having a paper retracted after X years or whatever. You can actually work quicker. That's the first thing. And the second thing is, yeah, you can also then just, be very honest with the people, and no one will can point fingers at you, telling you that you were hiding code on purpose. And then there's another argument, but people don't like to hear it, but I think it's a good one, is that you are being paid with public money. So public money, whatever you do should be public. That's unless there is a safety reason or whatever, but if not, public money, public code. That's the way I see it. But I know that it can be difficult to change people's minds on this, but yeah.
Just another question that came to my mind. We are trying to implement some kind of code quality control, if that's possible. Did you ever hear about any practice like this? Do you have experience in doing that? What people usually look at the code of each other to try to find mistakes and so on?
Well, I mean, it depends a bit on what it is you're doing. I mean, I think that most people would do in this situation is already to try to conform to some standards of how you write the code, a style guide. So that could be a first attempt, would be to say, well, we are going to use for example, for R, we are going to use the style guide of Google or of RStudio, so of POSIT, because they have a style guide and you can use that. And there's even a package that helps you, format your code in a proper way. And in Python, there is PEP8 standard that also does that. So that would kind of be the first thing. Then the other thing, really, to find mistakes, there's really only 2 solutions. Is people have to take the time to read it, to read your code. So your reviewers have to take the time to read your code. So the way you could do that is you work on some feature, and then if you're using Git, you can formalize that. You could do a pull request, and then people can review the pull request. If you're not using Git, you just ask people to you send your script and you ask people to take the time to read it. And then, of course, The other thing that you can do, or that someone else can do for you, it depends a bit how you organize yourselves, is to actually write unit tests. So this is really important as well. You write unit tests where you test your code against something that you know, and values that you know, and you essentially, each time you change the code, you rerun the unit tests, and you only trust your code if everything is green. But then you have to be careful, because you can also do mistakes when you write the unit tests, and you can also miss certain tests, right? Stuff that you could do, that you should do, but that you aren't doing. And here again, there is really no miracle solution. You just have to think very hard about it. Okay, what is it that actually my code is doing? What are some corner cases? Am I testing for these corner cases? What happens if the user, for example, enters garbage in the inputs of my function? Am I testing for that? So there are some, questions that you can ask yourself to help you. But here again, it's really only a matter of thinking, and if you have a colleague that is more experienced, that is great, because they can teach you. But yeah, it's there's no miracle solution. It's really, read and reread your code and write unit tests.
Is there something that you always use in those unit tests? So something that we should never miss when we are testing the code?
So again, it depends a bit on what I am doing. So I thought a bit about that, and something I do, if I am, for example, I have these pipelines that prepare data, and this data is kind of periodic. So I get like a new data set every month or whatever. So what I do is something I always do in these kind of situations is I write a test that tests the values of the previous year's aggregates. So I do some aggregations, and I save those results, and then I test that, because I want to catch any situation where this changes. It shouldn't change. So if it changes, that's really, alarming, or maybe not. Maybe there's a good reason, but I want to know that reason. So basically, I always write a test to test the past values, unless I have very good reason to believe that this will never change. But usually, if it's administrative data, there can be some revisions, there can be something. So it's always good to have this kind of tests of the past, let's say. So that is one thing that I will always test when I'm dealing with data like that. Another thing that I always add, but this depends a bit again on the functions, etc. But I always try to see, okay, what happens when the user inputs garbage, basically, so or whatever, or something totally wrong. So for example, the function expects a data frame, and the user just inputs some string or whatever. Now you get an error message, but sometimes you don't. Sometimes something weird happens, because maybe that argument gets passed to a function that knows how to handle both strings and data frames, right? But you don't want that. So this is kind of the things that I also always try to test as well, especially if there is something like an obvious mistake, right? So for example, if the user has to input some numbers. So for example, I have a function now in one package where the user has to input the like a number, a huge number like this, because it's an ID basically, and so I always try to catch exactly if the length is respected, and if not, I really want to return an informative error message. And so I test for that case, and I test for the informative error message. Do I get this informative error message to inform the user that something is wrong at that level? So this is, I guess, kind of the things that I always try to do. Yeah.
And then also talking about the data, when you share your projects openly, do you share the final tidy data after you went through these pipelines, or do you share the original data set and include the script used for cleaning it?
Yeah, so if I can share the raw data, I will share everything, raw data, script, and clean data. If I cannot share the raw data, so for example, this is the case with the open data from my ministry. So the open data is open, but the raw data is personal data from the citizens, so we cannot share that. So this obviously I don't share. So in the open data portal, you only have the code, the open data, so the aggregated open data. And I don't share the code in this situation because the code wouldn't bring anything, since the input data is missing. So in this case, it's really just the data. But if I can, I share everything.
Oh, sorry. Okay. There is another question saying that reproducibility requires large volume of storage space. This is against the recommendations to reduce the storage to fight climate change. How do you recommend dealing with that? And what is the minimum reproducibility requirements?
Yeah. So I am a bit surprised by this recommendation of limiting storage. I would more focus on computation, because storage, you can archive your projects, your environments, if you want, your Docker images in cold storage, and that doesn't, I mean, it's not even plugged into the electricity anymore, right? It's on some hard disk or on some USB key somewhere, and it's in a drawer, and that's it. And then if you need to retrieve that, you take your USB key and you can look at your code, at your data, at your computational environment that you stored. So I don't think, I mean, I'm a bit surprised by that this is a recommendation of limiting storage. I think the issue is more with computation, because building an environment, a complete environment like a Docker image, this can take a lot of computational resources, and that that literally uses electricity. And each time you push on GitHub Actions, for example, you start a build process, you start an image, and so on and so forth. So here, my recommendation actually is that reproducibility helps, because what you can do is you can define an environment, okay, with Docker, for example, that contains your R version and that contains your packages, and you build that once. So the image, you build it once, and then you share that image with the whole of your team, let's say 10 people. So these people, they're just going to use it. They don't have to rebuild anything. So instead of each team member building the same environment and using the resources 10 times, you build it once centrally, and then you just distribute the built image. So I would say that if you are clever in how you build these images and how you distribute them, you actually can end up saving resources. And it's the same if you're working alone, because if you're working alone, if you are using Docker, if you use the same base image and the same packages across projects, which is often the case because you always kind of work in the same field and the same type of data and so on. Well, if you build an image per project, the layers, so an image is divided into layers, the layers that are in common get shared. So they are not being rebuilt. So they're built once and they're shared across the projects. So there you save space and you save, again, computational resources. And it's the same if you use renv. So if you use renv to freeze the packages, if you do that for several projects, as long as the packages are in common, they will only get linked, right? You don't re-download them, you don't rebuild them. So I would say that the focus, I believe, should be more into the, into CPU, into really computation. This, I think, is where, it uses way more resources than storage. And actually, using these techniques, these reproducibility techniques, actually saves on both storage and CPU. So actually, I would say that reproducibility actually helps with fighting climate change, in my view.
And that's one more argument to show to those older senior researchers.
Absolutely, absolutely.
There is another related question saying, like, what is the computational cost of becoming reproducible? if we use several languages and use I don't know how to pronounce that, Venv and Brent.
Venv, yeah, Venv.
Yeah, and maybe other environments for each small project we are working on. Is it somehow getting computationally expensive and making things work slowly? Is there an optimal usage of these tools, or should we not worry ourselves?
So yeah, the short answer is don't worry about it, because essentially all projects, I mean, if you're using Docker, or even if you're just using Renv or venv, venv, or the Python equivalent, basically, every project is self-contained. You can have 50 projects. It's not, your computer is not going to get slower, or it's not going to get more complex. If you have a project where you use R and you use Python, you can build an environment with the requirements for both R and Python, using Docker, for example. And it's not it's not going to get computationally complex or slower. And as I said, if you have many projects that reuse many times the same Docker image, etc., this is all getting reused, so it's not using that much space in the end, and it's not getting that more complex, because it's the same stuff always getting reused. Now, of course, if you have different projects, and for all these different projects you have a different version of R, you have different packages, you have then it's getting bigger, but it's not like getting slower, or it's not getting more complex to work with, or whatever. It's just every project is self-contained, so it's not an issue. No.
As you mentioned other languages, how would you suggest the readers with a background in other programming languages like Python apply the advice from your book?
Yeah, so actually the Python users have already, most of them actually have already a very good habit, because in Python, it turns out that for a long time, and even today, if you want to install packages in Python, it can break very easily, because the Python works, or the way you publish packages in Python works very differently than the way you do that for R. For R, you actually submit to CRAN, your package gets reviewed by a human, and that human looks at the code and says, well, this is a good contribution, or it's not a good contribution. Now, they are not going to review the quality or whatever, but they are actually going to make sure that the package that you're publishing actually can serve a purpose. This is not the case with Python. In Python, anyone can publish anything at any time. And if your package somehow relies on an outdated version of another package, that's not a problem. It can stay on PyPy. So PyPy is the Python package index. So it's kind of the CRAN for Python. In R, it's not the case. If your package breaks something, it's never going to get published. And if your package is already published and some dependency gets removed, then your package gets removed as well, right? You only have 2 weeks to correct that. So basically what this means is that usually, or not usually, all of the time, whenever you install packages in R, you are sure it's going to work, because it's been curated. And this is not the case with Python. With Python, anything can break at any moment. And so because it's very fragile, the ecosystem is very fragile, they have been building per project virtual environments for years. And actually the tool that you read before, venv, that stands for virtual environment. And they have been doing that for years. So actually in Python, you already have a lot of the tools that we are now also using in R, like Renv. And so they already have this advantage that they should be familiar with that. So basically what they can do is they can take the book and they can read everything and apply, learn about Git, learn about Docker. But of course, instead of using the Rocket images, they're going to use the Python images. There are some Python images, official Python images that they can use. Instead of using Renv, they're going to use a venv. They can learn about functional programming. They can learn about this logic of packaging. Now, of course, they will need to check the documentation of the Python specific tools and learn about that. But the broad messages are still valid for Python. And I think even Python users or whoever can still learn quite a lot from the book.
Is there in Python also a package like Fusion?
Not that I am aware of. So I am not aware that there is something like Fusion in Python. And I think this is also kind of cultural. In Python, they use much more notebooks instead of something like Markdown or Quarto. This is maybe slowly changing because Quarto also supports Python now. But for the longest time, they were using notebooks, and notebooks are this kind of it looks like a script, but it's actually not a script. And so yeah, I think the reason there is not something like Fusen is because they focus mostly on notebooks. But also there was a question about about packaging. Should you always package your functions? And the answer is no. You don't necessarily have always to do it. You can of course just load your functions by sourcing the script, and you can do the same in Python. So you could, instead of writing a package and using something like Fusen, you could simply source your Python functions and use them in your pipeline.
Yeah. On that note, I would like to give my testimony. I was talking to Julia before you arrived. When we started the book club, I didn't know how to write functions. I was writing really complicated scripts, like with thousands of lines. And every time that I needed to change, so there was a lot of copy paste. And I had to read the script again and again and again to be sure that there were no mistakes in this copy paste. And with your book, so I presented a chapter on functions because it was a challenge to myself to learn it. And it changed so much my my workflow that now I have a package where, so instead of repeating the same analysis and copy pasting scripts, editing everything with the names of the new variables and things like this, I have a package where everyone who wants to have this type of analysis that many people ask me to do, I am just like, okay, there is something new here. I just go there and change in the package and it's done. It reduced a lot my time of working. So here's my testimony. It takes some time to learn it, but it's really worth it. So the time that you spend in the beginning, you're saving afterwards.
Well, thank you very much for this testimony. That's the kind of thing that really warms my heart, I must say. It's always nice when something you do helps people. And actually, your testimony reminds me of something that is very similar that happened to a colleague of mine when I was doing my PhD. I had this colleague that was working a bit like you described, so having these huge scripts without functions, copying, and exactly like you, copying and pasting, and then changing the variable names here and there. And it was always, did I make a copy paste mistake, blah, blah, blah. And so I was looking and reading. And one time I asked him, but why don't you write a function? Like, I don't get it. And he told me, but I don't know how to do it. I said, dude, we share the same office, just ask. So I showed him how to do it. And it was very easy because the like 99% of the code he had already written, because the logic, his loops and so on, that was the function. You just need to put the header and a return statement, and that's it. And so I do that. I show him, look, here is what you do, and this is your variables, like in math, this is what changes, blah, blah, blah. Okay. And then he re-executes the code with the function now. So I helped him write the loop to, execute the code of all the variables. And it ran instantly, because his script was so huge that there was a lot of overheads, and his script literally took minutes to run. And when he put everything inside a function, it took seconds. And just that time save of re-executing everything and now just taking seconds, immediately there, he was convinced that, functions are the way to go. And then he really forced himself to learn and to use them. So I was quite happy about that as well. And it's funny because the story you just told is reminded me of that anecdote.
Yes, I got so excited about this that I'm a data manager and I'm organizing our workshop. I will try to convert more people to
Nice.
functional code.
Great.
Okay, so yeah, as I gave an example here, there's a question. Can you provide an example where you could say you were saved thanks to one of the steps you described in the book?
Yeah. So so when I read that, I thought about this thing. There's like a saying or whatever that says, when everything works well, you don't notice it. You just notice things that aren't there. And that's it. I haven't had any problems where I can say, oh, I was saved because of this. Because if there had been a problem, it didn't appear. What I can tell you is what I told you at the beginning when we were working in this COVID time in that platform where we cannot install anything, where we couldn't have any Git, any RNV, any Docker, anything. Just trying to write as clean code as possible. That was the only thing we could do. There I could tell you we had many headaches, me and the team members, because we were running code and okay, why isn't this result the same as last week? Someone changed something, but who changed what, when? No idea. No code versioning, no nothing. So it was that. Yeah, so I can tell you about that. When we don't have these things, you have a lot of headaches. And this is standard. And also when I collaborated with my thesis advisor, he of course didn't know about Git and things like that, so we had to use Docker or email or whatever. And even with two people, it was a mess to just work on the same Word document. It's almost already impossible, and you're two, right? And with Git, you can be 20, and there's almost no issue. So yeah.
Unfortunately, it's actually a pity that one of the so there were two chapters that we had to skip because the meetings had to be canceled, and it's a
Yeah,
pity that one of them was on GitHub because it
yeah.
seems that it's one of the most important things. So is there something that you could advise us that is like really important and we shouldn't miss on GitHub? And I think the other one was also on freezing packages.
Yeah, right. So actually, yeah, I must say it's really a pity that you couldn't cover these chapters, because in the freezing packages, for example, chapter, I think I write something like, this is the cheapest thing that you can do is running this. And what I mean by this is using RNV, because if you use RNV, and there's a function called init for initialize, basically. If you do that, it generates a file called an rnv.lock file, and that file contains actually all the packages that are being used by your project with all the right versions and so on. And this file can be used in the future by RNV to re-download exactly the same packages. So this is really a very simple thing, I would say, that you can do to make sure that at least your project comes with a list of packages that was used. And then this list of packages, you can use that to rebuild later if you want, and if you need, you can use that to rebuild later your environment. So I would say that this is a very simple thing that you can use. And then yeah, Git is, in my opinion, it's one of those things where actually I even wrote in my notes that today I would not consider someone to hire someone that doesn't know Git, unless that person is willing to learn, and we have, of course, the time and the budget to train that person. Then fine. But it's really, in my case, Git is this kind of thing where it's very hard to explain to someone that doesn't use it why it's so good. But once you learn it and once you start using it, you cannot imagine how your life was before. It's really this kind of thing where, yeah, it's like, imagine you bring a fridge back to the 19th century, and people start using it, and they were like, okay, what were we doing before? So it's this kind of tool that is absolutely mandatory today. And it's not that hard. It looks very intimidating, and yeah, it is at first when you're like, whoa, wow, what the hell is this? But if you take, honestly, after a couple of days already, you know enough to already be dangerous, let's say. And then, you know, with experience, it becomes really irreplaceable. And if you go further, right, if you then combine Git with GitHub Actions, for example, if you're using GitHub Actions, the same thing. It's this kind of thing where, wow, once it clicks, and once you know how to use it, it's amazing. So I would really highly recommend to everyone to really take the time to go through these chapters. And you know, if you have questions or whatever, just send me an email, and I'll be glad to answer them. There's no problem there.
Very quickly, what are the GitHub Actions?
So GitHub Actions. So on each Git platform, so you have GitHub, you have GitLab, you have Bitbucket, etc., etc. You have many providers, but on all these providers, what you can do is you can add on top of it what they call runners. And basically, a runner is a computer that will execute whatever each time you do something. And so basically, what happens is that each time you push, for example, you do some change in your code, you change something and you push, what is going to happen is this is going to go on GitHub, and then the runner is going to start. And let's say that you told the runner to run unit tests, for example. So the runner will start and will run the unit tests. And if everything is green, then no problem. If you have a problem somewhere, everyone on the team gets an email saying, hey, the code is broken in this place. So this means that you don't have to run the tests locally, for example, they are run centrally. And this again, you know, to go back to the climate change question, etc. You can also configure that to not run each time you push, but maybe to just run every day at midnight, for example. So every night it runs, and then in the morning you get your report and you see if everything is well. Or for example, something else that you can do, and this I can, if you want later, I can show you that as well. When I write a paper, and now, even though I'm not a researcher anymore, I sometimes am involved in some research projects. And now I have a repository that I can show you, where basically I just write the paper. It's a Quarto file. I just write it and I push. And the paper gets compiled on GitHub Actions, and the PDF gets saved there. So I don't need to have, you know, the whole LaTeX, etc., installed on my computer, and my co-author doesn't need that either. And it's a good thing, because when we started, he is on Mac and I am on Linux. And what happened is that we didn't have exactly the same fonts. So the document was always kind of changing the font a little bit depending on who was pushing. And so I said, okay, enough. So I configured GitHub Actions to compile the paper, and it's always now the same. And yeah, and it's very, very comfortable tool, because you can automate basically anything, literally. Another thing that you can do, you just wrote a package, you told us, you can actually very easily create a website for your package using a package called package down. It's very easy. Package down, you can build a website. When you push, if you are working on GitHub, if you push your package to GitHub with package down, this will automatically configure a runner to build the website and publish the website on GitHub pages for you. So you don't have to do anything. You just push, bam, you have a website in 5 minutes. So yeah, GitHub Actions, extremely powerful tool. And it's the same as Git, right? Is okay, it looks intimidating because you have to configure it, blah, blah, blah. And it is a bit complicated, I'm not going to lie. But if you take the time, and if you start seeing the benefits, and then it saves you an incredible amount of time down the road. Like you become much more productive, and also much more relaxed, because you always know, okay, my actions are running the tests for me, and if something's wrong, they will tell me. And that's really important, especially if you're working on a team with more than 2 or 3 people. There is always someone that is going to forget to run the tests beforehand or whatever. You don't have to think about it anymore. Just push, and it's going to happen in the cloud for you. And it's free. GitHub Actions is free for public repositories.
Sounds amazing. I have been running the package every time that I do the tests. I'm doing it locally, so it sounds good.
Yeah.
I will take a look at it. And there is this question. It was, I'm very interested in the answer. What skills or methods mentioned in the book are essential for standing out as a data analyst? For example, what do you think could give us an advantage in getting a job?
Yeah, so I mean, depends a bit on your field, but honestly, someone today that, for me, someone that kind of, let's say, studied economics, sociology, psychology, biology, chemistry, whatever, some kind of field, right? You have a person like that that knows the field and at the same time knows enough about software engineering, software carpentry, knows about Git, knows about Docker, knows about reproducibility, knows about something like GitHub Actions. Profiles like that are amazing because you work with someone that not only knows the field, so someone that knows how to talk to the field experts, to the researchers, to the consultants, whatever, and at the same time knows as well how to write quality code, how to work with the data engineers and whatever. If you are in that intersection, it's incredible. So I would highly recommend to really know Git for sure. Git is super important. Know about unit tests, know how to write unit tests, know about generating documentation and writing documentation, knowing how to automate stuff using GitHub Actions or even just scripts. So it's not just, you can use R, for example, not just for doing your statistics or whatever, but you can then write scripts to also send automated emails or clean Excel files or whatever. That is very, very valuable. So and also there was a question about Shiny, and also Shiny I think would be quite important, because if you learn about Shiny, actually there are several things you can learn about Shiny, how to make a Shiny app, and that already is quite interesting. But if you learn also how to deploy such a Shiny app, and this is very technical, but if you know roughly how it works and if you know how to do it, you can then talk also to the IT infrastructure team, and you talk the same language all of a sudden. You understand each other. And so it's kind of having this broad, view of who does what, and having these communication skills and being kind of in the middle where I think the value is. So I would say, don't just focus on your field. That is super important, but also look at IT, right, and at software carpentry, and ideally, if you can, look as well as at regulations that impact your field. That is also quite interesting. If you have legal experts, etc., in your institution, go grab a coffee with them, discuss about regulations, about problems like that. Try to involve them as well as soon as there is a new data collection going on or something like that. Talk to them. They would be very happy to be involved, and especially it's very important as well to know what you are actually allowed to do. So yeah, to make in summary, you have to dab, in my opinion, in these different things, and you have to communicate with everyone. You need to be able to communicate with everyone, basically.
So this was the question I was most curious about the answer. All right. The question about Shiny is, do you use Shiny often? I did not delve into it yet, and not sure if it could be useful to invest the time to learn it.
Okay. So I don't know if I would say I use it often. I mean, I use it. So we have, for example, one of the well, actually, I can show you. We published a dash. So my ministry. I mean, I wrote the dashboard, and it's published by my ministry. We have a publicly accessible dashboard that shows our open data that you can access here. And this is a Shiny dashboard. And we also have some, internal, I'm working on some internal dashboards as well with some, sensitive data and things like that. Also, what I do sometimes is when a colleague comes to me and says, hey, I have every week I get this Excel report and I have to analyze some data. What can I do? So sometimes I write them a Shiny app, and so they just upload the Excel and they get whatever results they want immediately. So I do use it. I'm not an expert. I think it's a very cool tool. I think that it doesn't take a lot of time to learn, and it does make things very, very interesting in certain situations. Also for teaching, for example, because you can then have some dynamic, if you want to show some, I don't know, some optimization algorithm or whatever, you can change values dynamically and you see how the results evolve, things like that you can do. So I would say take the time to learn it. It doesn't take a lot of time, actually. You can have some basic apps going quite quickly. And honestly, I think it can be quite valuable. It's again this kind of thing where it might be a bit difficult at first to see why it's useful. But I was last week I was in France for our users conference, Rencontre R. And a lot of people, a lot of teams there presented their Shiny apps that they do internally as a way for experts of a certain field to be able to run some analysis. So basically you have, the data scientist or the data analyst or whatever, the R user, the R programmer that builds this app where the researchers only need to upload some data or upload pictures or whatever, and then they can do their analysis like as a graphical way, right? So these are things that you can do as well to support your team members instead of having them do their things in Excel, and they also don't really know Excel either. So you can build like a business app, let's say, for them. So this is quite useful as well.
Yeah, thinking again on academia, maybe for citizen science, it could be a good idea, right?
Yeah, to involve the citizens, involve students, involve for sure. I think as a communication tool, also to share your results, it can be quite interesting as well, because you could have, if depending on what you do, if your results are dynamic or whatever, or if there are many of them, people can easily click and change countries, for example, or change subjects or whatever, and have a report for that. So that's actually quite interesting as well. There's, for example, also the linguists here in the University of Luxembourg. The linguists, they are developing an app for Luxembourgish. So you have several maps with the dialects that are spoken and how people pronounce it. So they actually linked that to an Android app that people could use to record themselves pronounce certain words. And now you can listen to that. So it's quite interesting as well, and it's publicly available. Maybe I can find it, and yeah, it's quite nice as well.
While you're searching, there are any additional resources that you would recommend for someone who has read your book and wants to learn more?
Well, there is the how is it called? I have to there is a book by the people from the UK, from the ONS. Wait, maybe wait. I have the link here actually, because I prepared the questions. Yeah, here it is. So I would look at that. 1 second. So I would look at that for sure. Where's the chat? Here it is. So I would look at that. And then I would also look basically at every piece of documentation so for example, if you want to learn Git, right? Use whatever medium works best for you. If you prefer reading, okay, read the Git book. There is like a Git book. If you Google Git book, read that. Then maybe Google, Git for our users. There is actually there is like the Happy Git, I think, by Jenny Bryan. I can also link that. You could read that. If you prefer videos, go on YouTube and just look, Git for our users or just Git, right? You can just look at that as well. And then, most importantly, just do stuff. Just ask yourself the question, okay, how do I actually do that? How do I do a Shiny app, for example, or how do I do a targets pipeline and put that on GitHub? How? Just do it. Just do it. And when you have a problem, ask for help. You open, and for example, you open a thread on the POSIT community, for example, or you go on some Slack. I'm pretty sure you probably have I guess an Our Ladies Slack or something like that. That you ask for help. Send me an email. Doesn't matter. But like nothing beats doing. You can just do stuff. And that's really the that's also what I tell my students. I teach so basically every year I teach this reproducible pipelines here at university for 20 hours, and I just tell them just do it, just do something, just ask yourself the question, even if it's something simple, like you want to learn ggplot, maybe you don't know ggplot, look at a graph and ask yourself, okay, how do I make this graph? And just start Googling and start asking ChatGPT and whatever, and just do it. And that's really the only thing that, at least for me, really works at the end. You can read a lot of things, and it's important to read. I'm not saying you shouldn't. I write stuff, so you should. So I'm happy that you read my stuff, but at some point you just have to get your hands dirty. You just have to do it. You just ask yourself the question, and don't take no for an answer. Like, don't take failure for an answer. If you can't do it, ask for help. Just ask. And it's incredible how happy people, most people at least, are happy to help. If you ask them stuff about stuff that they do, right, they are happy to answer. Look, I am here, answering questions, and a lot of other people are like that. Most people, actually, at least in my experience. Maybe I was lucky, I don't know, but usually when you ask people about things that they care about, they are happy to answer. So if you ask someone about Git and R, etc., in the right community, they will be happy to answer. So yeah, my recommendation is really, just do stuff. Just do it.
We have another suggestion in the chat saying another source for getting help, DS Learning Community, former R4DS. That is the link. And I think for who is watching on Our Ladies YouTube channel, we can put all of the links that are here in the chat now. We can put them in the description.
Yeah. So yeah, that's the Slack of the of that data science community. Yeah, just ask for help. And by the way, here is the link to the Shiny app that is for Luxembourgish. So from the linguists, at the university, and you can change the language of the app to English to help you go through it. But if you speak German, you I guess should be able to navigate the app in Luxembourgish. So.
Nice. Okay, and we have the last question from the list now. It's a bit more philosophical, I think, or I don't know. How do you envision the future of reproducible analytical pipelines in the field of data science?
Yeah. Well, as I said before, a lot of data scientists actually use Python. So if we're really just looking at data science, because a lot of data scientists use Python, and because most Python users already use virtual environments and things like that, I think that this best practices of having project-specific virtual environments are going to continue getting used. Also, I see that there is more and more a trend towards more and more functional programming and more, making sure you have concise codes and making sure that you have pipelines. So I see a lot of pipelining tools coming out, as also for data engineering, like Airflow, MLflow, all these kind of things that are that come out. So I think that we will go towards more and more of that. And yeah, so I'm pretty confident that in the future there will be more tools and more people trained to actually do it, and more awareness of these techniques. So I'm pretty confident about it, yeah. And not just in data science.
Yeah. So these were the questions of the list. I don't know if you would like, you mentioned you have a new package. If you want to talk about it, or if someone has in the audience has a question. Now we have some spare 15 minutes.
Yeah. So if there's a question, I'm happy to take it. If not, while people type questions, maybe I can just prepare a little something that I can show you, and then I can talk indeed about the package. I would be happy to do so. Yeah, so let me share my screen. So first, before showing you the package, I'm going to show you a little bit GitHub Actions very quickly. Oops, no, that is actually my colleagues from the app. Yeah, voila. So do you see my GitHub? Yeah, you see my screen now.
Yes.
Yeah. So this is a GitHub repository, okay? And you can work with a GitHub repository from your computer or from the web interface. So this is the web interface of this GitHub repository. And basically, what I just want to show you is this is the code to my paper, okay? It's a QMD file, and I can change it here online, okay? I can also work from my computer, but I'm going to show you I can change it here online. And when I change it, when I click here, commit changes, this is going to actually do a push and a commit, like if I was working from my computer. So I'm working online, so I'm going to commit the changes online. And now if I go on actions, what I see here is that I configured my actions here to run. And this is essentially going to compile my paper online. So what is going to happen is that this thing is going to get installed, the environment and so on is going to get installed. It's going to use a cache, and it's going to upload my paper once it's done. And maybe I can show you. So if I show you past actions, 2 weeks ago, maybe it's still there. Yeah, you see here is the paper. So if I click there, and if I open it, yeah, here is the PDF, and here is the paper that has not been published yet, but hopefully it will. And this is the paper that was built online. So now this is the one from 2 weeks ago, but now if I go back on my actions, maybe it's still, yeah, it's still running, but this is now, compiling with the change from before. So this is basically GitHub Actions, okay? I just triggered this build, and now it's building this environment, and it's, rendering the paper and uploading the paper. And so this is one example, but there are other examples that you can do. You can do a lot of things with GitHub Actions, and you can configure it to do basically anything you want. So that's the first thing I just wanted to show you. Are there any questions on this, perhaps? Just, I mean, it was a extremely short introduction, but.
I have a question.
Yes.
Thank you, Bruno, for dedicating this time.
No worries.
Bruno, this is a very wonderful the action in GitHub. I'm not use now GitHub action, but how can we how can we say to Git to do an action? It's something very difficult, or no?
So let me show you again. So that's a good question. Actually, I didn't show that, and I should. So basically, to configure your action, you have a file here. You have this folder, GitHub workflows, and inside of this folder, you have this YAML file. And this YAML file is where you say, okay, each time you push, or each time at midnight or whatever, you will do these things. So each step has a name and uses an action or runs something. So you see here, I run, Quarto run, etc., etc. So again, if you don't have any experience with this, it can look a bit complicated, but it's not as hard as it looks. First of all, you have a lot of, and I can show you this as well. You have actually this thing, rlib actions. These are GitHub actions for the R community. So basically, you can go here and read about all the actions that are available to you. And there's a blog post that helps you get started. And this explains to you how you can use actions for R to compile papers, to run tests, to do whatever. So you have this resource that I can also put in the chat that you can use. And then yeah, it's really a matter of Googling for examples, using ChatGPT for examples, asking for help, again, to say, hey, I would like to do that. How do I do it? Of course, it helps if you are already a bit familiar with Linux, because actually these actions, they are running on Linux, and you can actually run any Linux command on them. You can literally type whatever and it will work. If you are not familiar with Linux, that's not an issue. It's just that it helps. So if you're not familiar, you can use these actions that I linked here in the chat. And these actions are if you want, pre-written for you. So you can say, yeah, I want R with so-and-so and so-and-so packages. And the action there will do that for you. So yeah, I mean, there are a lot of resources here that you can use. And again, just try and ask for help. Yeah.
Thank you very much.
Sure.
More questions?
Okay, so if not, I can maybe talk about my my other package. So I will share the screen again. So this is a bit more, so this will probably next year or in 2 years, I don't know, this will probably become like a new chapter in the book, maybe 2 or 3 new chapters, it depends a bit. This is a package called RIX. And this package, basically, it's not yet on CRAN. We are going to try to submit it before the summer or during the summer. We will see how it goes with my co-author, Philipp Baumann. Basically, what this package does is that it generates for you so-called default.nix files. So I can show you what such a file looks like and what do these files do. So basically, this package generates for you something like this. It generates this file with all this text, everywhere for you, okay? And the way it does that is that you just need to say, well, maybe you just need to write something like this, okay? You need to write something like this. It uses the RIX function. And you say, well, I want this version of R, I want these packages, I want this, I want that. And then it generates this file that you see here for you. And what is this file? So this file is a so-called default.nix file over here. And it's written in the Nix programming language. Okay, so, and what is Nix? Now, that's the question. So Nix, and I can show you here as well on the website, Nix is actually a lot of things. It's a programming language. So this default.nix file are written in the Nix language. So it's a programming language. But it's most importantly, it's a package manager. And it's a package manager with over 100,000 packages, okay? And so, for example, among these package managers, you have the among these packages, you have the R packages, for example, here like dplyr. Okay, so you have dplyr, for example, here for this for dplyr, or whatever. If we go with chronicler, you have your chronicler is here, and so on. So you have all the R packages there, and of course you have RStudio, and you have R, and so on and so forth. And what this means, it means that basically when you write this file here, this file is going to install these packages for you, and it's going to install R, it's going to install R packages. You can install Python with it. You can install RStudio, as I showed you. Where is the as I showed you, there is RStudio. You can install Python packages. You can, as they say here, there's more than 100,000 packages. And so here, packages, it's not just R packages, it's any type of software. You can install RStudio, Vim, Emacs, Firefox, even if you want, whatever. And so this means that you can install development environments, basically rigs here. What you can do is you can say, well, I have this project. Let me pick an example, perhaps that is, maybe this one. I have this project, and for this project, I want RStudio, and I want dplyr, and I want ggplot, and I want the latest version of R. Okay, or maybe instead of the latest version of R, you can say, well, I want, let me show you, maybe another, maybe something like this. Yeah, latest here. It's all using latest, but you can use Quarto, you can use tech packages, but you can also add, basically as before, maybe if I go in the reference, you can basically add here all these versions of R. Okay, so you can all these versions of R. You can say I want this version and I want this and that. And so what it's going to happen is that once you have this default.nix file that is here, this default.nix file, you can use the Nix package manager to install all the software that is listed here. Okay, and all this software basically what's going to happen is that once it's going to install R, it's going to install the R packages, and it's going to install all the dependencies of the R packages and of R and of RStudio, and it's going to install all the dependencies to these dependencies, and so on and so forth and so forth. So basically, using one single tool, using Nix, you can actually replace Docker and renv and every other tool. Actually, this tool covers everything, because the goal of this tool, the goal of Nix, is to be able to install packages in an absolute reproducible manner. So whatever you install, you will always get exactly the same versions of all the tools and of all the dependencies. And because it's kind of a complex tool, we wrote this package because then this package allows you to, very, very simply, if you go here, you can just say, okay, I want this version of R, I want these packages, I want this, I want that. And then this is going to build, if you go here, there's this example. This is going to build.
We don't see your screen anymore.
Yeah, sorry. Yeah, thanks. I was I was scrolling. If you go here, you see, you just add these arguments, and it's going to build this file for you, right? That I showed you, something that looks like this, very complex, but it's generated by a computer. And then you can use this file, you can use that to build an environment. And I can also, so I did a presentation in France last week. So, and in this, so it's in French, but the presentation has two or three videos. So let me, okay, so where's this? Okay, that's weird. The slides are not showing anymore. Okay, I just need the, actually I can go on my YouTube channel, that's easier. I just want to show you how it looks like from yeah, it should go to YouTube Studio, because they're not, these are not public, they're like 2 or 3 very small channel videos. Yeah, here it is. So basically what this does, so here I am on, so here I use the terminal because it was just for the demo, but you can use RStudio. So here basically I have this generate R file, and this generate env file is going to build this default.nix. Okay, so I can show you here. So this is the code, you know, I call the Rix function. I want this version of R, I want these packages and so on, right? And now I'm going, so this generated my default.nix. So I can show you, it looks like this, very complicated, but it doesn't matter because it was made by a computer. So now, as you see, here I use which R. What this does is that this tells me where R is installed. So R is installed here. So this is on a Linux computer. Okay, so this is my main R. And so the version I have is I have R433. Okay, so this is the version I have installed on my computer. But now I'm going to build an environment using Nix build. And this is going to build an environment with another version of R. So now if I go on, if I do Nix shell, now I enter this new development environment. So at first I did Nix build, now I do Nix shell. And now if I do which R, you see that the path to this installed version of R is totally different, and the version of R is different as well. It's a different version than the one that I have installed on my main computer. So here I have R version 4.3.1 now. And I have, you know, dplyr, and I have a ggplot. And so basically what this means is that you can have, for all environments, for all projects that you have, you can define a default.nix file. And this default.nix file has everything you need to run your code. It has the packages, it has R, it has Python if you need it, Julia, whatever. It has RStudio if you need it, Emacs, Vim, whatever you need, whatever you use, you can have it. And you can, for each environment, have a separate development environment and use it. And just like with Docker, it reuses the packages. So if you have the same stuff, you know, in common, it's going to get reused. So that's not an issue. And it's nice because it's one tool that handles everything. And so probably, you know, this is still in development and it's not a very easy tool. Nix is not a very easy tool, but we're trying with this package to make it more accessible. And yeah, it's very likely that, you know, in 1 year or 2, or whenever I feel ready, that I will add some chapters to the book on Nix, because I think that it is a very, very powerful tool that, yeah, I think can make a huge difference in the future to make, you know, reproducible projects.
Amazing. Is it functional already? Is it already working if we would download it from your GitHub account?
So yeah, so it works. You can use it. So it's not on CRAN, but it works. The main requirement though is that you install Nix, right? And so I can show you perhaps very quickly. What I highly recommend is that you go through the vignettes, getting started, setting up rigs on Linux and Windows, or on Mac if you're on Mac, etc., etc. So you have to, if you want to use this, you have to install Nix first. And we explain here how, for example, if you are on Windows, we say, okay, you know, on Windows, you actually need WSL. So you need this thing to be activated on your Windows computer. And you can read, you know, the official Microsoft documentation. And we try to explain it as much as possible. If you are on Linux, it's a bit easier. And if you are on Mac, you should read these vignettes. Also, you should be aware that Mac has some, you know, Mac OS specificities that you should know about. So we highly recommend to read these vignettes. But yeah, as I said, it's not a super easy tool to get into. It's extremely powerful, but it's not a super easy Nix tool to get into. We are trying through the package because the package generates these files for you. And also we try to put in as much documentation as possible to explain things. And hopefully, you know, in 1 or 2 years, whenever we'll be ready, you know, I can add some chapters to the book to make it even easier. But yeah, the package works. If you install Nix and if you install the package, you can literally use it today to start, you know, generating these default.nix files to build reproducible environments. Yeah.
I don't know what Julia thinks about it, but maybe we could make a follow-up meeting with the checking this package. What do you think?
I mean, I can join if you want and answer some questions. No,
Oh.
if you want.
That's brilliant.
Yeah,
No problem.
it looks very promising, the package and this next system. So I will surely check it out.
Yeah. So there's a question in the chat, like, can I take Nix as Anaconda? Yes and no. So this is a question that I get asked often, also in France when I presented it. There are some commonalities for sure. The main difference, though, is that unlike Anaconda, Nix installs the dependencies of the dependencies of the dependencies and so on and so forth. So Nix considers one piece of software, one package, not just alone, but as a full closure, they call it. Like it's a full set and the whole set gets installed. And the advantage of that is that you can ensure reproducibility, because if you can install it once, usually it should work always anywhere. And you can also pin the versions. So you can say, maybe this I should show you because it's going to be a bit difficult to describe, but you can say something like, let me just, do I have, no, not here, but probably, yeah, maybe if I go on the GitHub. Basically, you can pin a very specific version. You see this thing. This is done automatically for you as well. And you can pin a very specific version of essentially Nix packages. So Nix packages is where all the packages come from. And you can pin a very specific version of Nix packages. Again, this is done for you. But what this means is that if once this is pinned, once this is selected, every time you're going to evaluate this expression, you're going to get exactly the same packages. So it's something that, you know, wherever you are going to install, you're going to get exactly the same stuff. And so it's more reproducible than Anaconda. It's also more robust, because I don't know if they are better now, but when I used Anaconda in the past, it used to be very difficult sometimes, because some packages would break and Anaconda would have a very hard time to solve the dependency graph. And sometimes I would get a message like, you know, you can't install this unless you downgrade these other packages, or if you upgrade them. And so I would upgrade, but then upgrading those, I need to downgrade some others, and so on. So it would be a mess. With Nix, you don't have that. At each state, you have, it's going to work. Now, of course, now to be fair, there are some packages that are broken on Nix, because this happens. There are packages that are broken, and it's not necessarily related to Nix itself, but there are packages that, for example, require some. We had the case recently. There is a package that is broken currently, and it's a package from Bioconductor. And that package from Bioconductor has a dependency on a package from CRAN. And this dependency, this CRAN package, has been removed from CRAN. And so you just cannot install that package, but it's still available through Nix because it's listed there as being available. But if you try to install it, it's not going to work. But it's the same, actually, if you try to install it now with R. If you just try to install it now, you're going to have the same message, same error message, that this dependency cannot be satisfied. So there are broken things on Nix, but it's very rarely at least in my experience, very rarely due to some NICS issue and not to some package issue, because NICS is extremely strict on how packages need to be installed, because this is how it ensures reproducibility. And so this means that if there is anything wrong with the package where reproducibility cannot be ensured, that package is going to be broken. And sometimes it's a bit too strict. We have packages that are broken and we fix them. When I say we, it's myself and some other people that use NICS with R. We fix them regularly. And yes, it needs some manual intervention. So it can happen if you try to use NICS and if you try to install some package that it's not going to work for some reason. And this is because you were unlucky and you stumbled upon that one package that doesn't work. So for example, currently there are around, I would say, 50 to 60 packages from CRAN and Bioconductor that don't work on NICS. And we're trying to fix them, but some are, we don't even know what's wrong. They just don't work. So, yeah.
Thank you very much, and thanks for this extra presentation of the package that you're working on. Yeah, it was really a great meeting, and we thank you, all the participants, and yeah, let's keep in touch. Maybe we can do some meeting about RICS.
Yeah, with pleasure. I would be quite happy to talk about it.
Wonderful. Thank you very much, everybody, once again, and have a good summer.
Yeah.
Well, thank you very much for again the opportunity, and thank you. And yeah, as I said, if there are any questions regarding the book, regarding NICS, whatever, if you're trying stuff and it doesn't work or whatever, just send me an email and I'll try my best to answer and to help you.
Thank you so much. Learned a lot.
Bye-bye.
Bye.
Thank you. Bye-bye. Thank you very much.